Good morning, everybody. And thank you, Bruce. That was awesome. That was one of the best AI explanations I've heard. So I'm Marten Mickos. I'm CEO of HackerOne. We are the leading company doing vulnerability disclosure. We find one critical vulnerability every hour among our customers, and then they fix it so that threat actors can't act. And I'm here to talk about cybersecurity and open source as well. I was previously, some may know, the CEO of MySQL. I used to say the first, the last, and the only CEO of that company a long time ago when open source was smaller. And in cybersecurity and in security, we have to work on the problems. It's a practice where we work on the problems, but it's very important to be focused on the opportunities. So I will take a positive view on all that's crappy and bad and vulnerable and broken with software, because they're all just opportunities, and when we fix things, things get better. And if we don't believe in a better future, we will do nothing in cybersecurity. Of course, the problem with society today is that most people do nothing about cybersecurity because they are so afraid of it. They can't touch it, they can't see it, they can't face it. They just think that it may go away if they do nothing. And we will never be secure until everybody thinks about security. That's why I'm saying there's just one way to do security, and it is together. It's not for the people with clearance. It's not for programs of secrecy. This is something everybody needs to work together on, not just the technical experts, but everybody in the world. Nobody is as well equipped to do that than the open source communities, because that's an area where everybody is working together. And I've said many times that the power of open source is not that we agree and get stuff done. It is that we disagree and get stuff done. That's the true power of it, when you have a governance model that allows people who have nothing in common to actually produce something in common. That is why open source is so powerful today. It's much more powerful than 24 years ago when I started looking into it, and it was like most projects were cute small projects. Today it's massive. And I've learned over nearly a decade in cybersecurity. I joined cybersecurity knowing nothing about it, and they made me the CEO from day one. Well, now I've done it for 10 years, and I've learned some things. I'm still incompetent and weak and incapable to do this, but I've learned some things. One is, and it's very good news, cybersecurity is essentially a math game. I thought it would be some magic and voodoo and stuff like that, but it's actually just mathematics. And mathematical problems lend themselves to working together, to spreading out the work, to distributing the work. And maybe the most important mathematical rule of cybersecurity is that timing is everything. You can have the shittiest defense, but if it is the fastest, it works. And we tend to, especially vendors, tend to say you must have this endpoint protection, you must have this tool, you must have this thing. What really matters for a company or an organization defending itself is how fast they defend themselves. And that is the key to good cybersecurity. Then we've learned that over time, everything gets more complicated. I remember when the internet had 4 million users, and I remember when it had 40 million users. Now it's billions and trillions and gazillions, and everything is interconnected. So whatever solution we thought we had yesterday, it's much more complex today. Other things as well, I won't go through all the bullet points here, but these are mathematical rules or principles that govern a lot of cybersecurity. And I say there in the middle, pool defense is the only sustainable defense. Given that the threat is asymmetric, the only way to, and the most powerful way to defend against any adversaries is to work together. When the good guys work together, they are far more than the bad guys. We know it at HackerOne. We have 2 million ethical hackers signed up in our network. That's more than there are cyber criminals and rogue states or cyber people working for rogue states in the whole world. So that we already in our network, we have more good guys than there are bad guys. And of course, by guys, I don't need specifically a gender, although most ethical hackers are men. I mean men and women, young and old. Just happen to use the word guys here. So I'll give you some examples of security where we work together, where the world works together. And here's a model that's called Defense in Depth. I added defense in collaboration. It turns out that to make systems really safe and secure, you need multiple layers of defense, multiple lines of defense. It's not enough to just test it once. It's not enough to design it once. It's not enough to do just one thing. You have to do all these things. And you start with the principle of security by design, which has been developed over many, many years already. It has now been formalized by CISA, the US government, in a program they rolled out this year, saying everybody needs to start by designing their software to be secure. And then you add layer upon layer upon layer to remove vulnerabilities and also to feed the information back. So if you jump to the last line of defense, a bug bounty or a vulnerability disclosure program will find the most critical, novel, elusive bugs. So it's the most powerful way of testing, but you should have done all the other ways first. And what you find there, you feed back into your design paradigm to make sure that you don't make that mistake again, because you will make other mistakes. There are more vulnerabilities to go. Even if you eradicate a whole category, there are more vulnerabilities to go. So we should eradicate whole categories of vulnerabilities. Cross-site scripting is something which I'm sure technology and time will eradicate at some point. Now it's the most common vulnerability, web vulnerability in the world, but tools are evolving, browsers are evolving, so that at some point they won't exist anymore. So this is an example of where people can work together, groups can work together, and they can learn from each other, sharing the knowledge and move information up and down this chain so that every line of defense learns from the other lines of defense. Here's another example. If you read Sonatype's new report, it's an amazing report. They are saying that open source adoption has reached a multi-trillion request scale. So the request for open source libraries and components is on a multi-trillion level today. It's crazy. Like, how can there be so many requests? And it is, in a way, just the beginning. When AI starts building more software, these numbers will just go through the roof. And it's all based on open source software. Like Todd said that, what was it? 98% of all software includes open source. The bad news is the malicious packages and attacks are on the rise, and they had discovered 500,000 malicious packages since November 2023. So in 1 year, 500,000 distinct packages that have malicious nature in this volume of multi-trillion requests. And there are known vulnerabilities that remain unfixed or unmitigated. We can talk about Log4j and Logshell, and we can remember when it was known and tested and all of that. There's still software out there that uses the old versions that haven't been patched, that are still vulnerable to this thing. So we have to be reminded that this work will never end. We'll have to keep looking, and removing vulnerabilities every day. Yet with a good spirit and a good mood, never seeing it as a burden, but as an opportunity to build a safer world for everybody. Here's another open source example, curl. Daniel Stenberg, Swedish open source developer, started building tools for copying URLs, and it has ballooned into one of the leading open source projects in terms of instances deployed. He estimates that it's over 20 billion, every mobile phone, every IoT device, multiple instances per device. They run a bug bounty program. I'm proud to say it is a HackerOne bug bounty program. We have a nonprofit called Internet Bug Bounty, where corporations will give us at HackerOne money, and we pay out bounties for open source projects who can't afford it themselves. And the brilliant mechanism that we invented a couple of years ago was that of the money, we give 80% to the finder, to the ethical hacker, but we give 20% to the project. Because the project needs to be funded to make sure that everything gets patched, that the bugs gets fixed, so it would be wrong to give all the money to the finder. This has made it very attractive for open source projects to join the Internet Bug Bounty, because they not only can fund their bug bounty program, they can fund some of their own security work as well. So Daniel just wrote a blog about it. You can go and check it out. He ends with his own advice. He says, I think the curl bug bounty is an absolute and undisputed success. I believe it's a key part in our mission to keep our users safe and secure. Next one, AI. today, there is no software project where it isn't an AI dimension. And it's coming into everything we do with software. We just have to be ready for it. So about half a year ago, we tested 100 websites of leading AI vendors and deployers and companies who said we have an AI product. So 100 websites, and we checked what they are saying about safety and security. Because in this group, everybody will agree that governance is important, safety is important, security is important, transparency is important. I don't have problems agreeing with you here. But look what the reality is in the world. Out of these 100 corporate websites, over half of them say nothing about these topics. 70% state they have a policy, but they don't share it. So they sort of, who knows whether they really have one. 12 state the policy and compliance standards. Okay, we're getting somewhere. 13% state the policy and also refer to external testing and validation. And now we're getting there. And 5% proactively communicate and discuss AI safety and security in public. So it's a very small portion today, which means that all you guys here working with open source and security, there will be a deluge with all AI systems that will fall in your laps, and somehow you have to test them, or you will be exposed to them, or somebody will ask you to interact with them. And they are not very secure today. We do AI red teaming at HackerOne, so we test for all these weird behaviors, not just the vulnerabilities, but also violations of privacy. Like we did a test for Snap on their AI deployment, and Snap said, this AI deployment can make you can make images on it, but you can't make offensive images. And then our ethical hackers showed you how to make offensive images. And then they said, you can make images of humans, but not of naked humans. And then the ethical hackers showed how to do that. So the testing is now much broader. It's not just the cross-site scripting and code injection or prompt injection. It's safety features that are as bad for society as vulnerabilities. But we're getting there. It's getting better every day, so I remain an optimist. So therefore, I've come up with this. I'm borrowing from Kim Scott. She's the inventor of radical candor. She wrote books about it. Her thinking is so perfectly aligned with open source and secure open source software. So I borrowed the term and thought, what if we could agree on something like radical software candor? And the bullet points there is just me dreaming up things in an evening, so don't take it as very well thought through. I share it with you so that you can improve of it. But what if we had some sort of standard of what radical software candor would really mean? How open can we be with software, with weights, with parameters, with deployments, with bias in systems? Like, how far can we go? Because I do think the only thing that will work long-term is a thing that can be tested and validated from the outside. So sure, security by design, we have open software supply chains, open source, but also an open supply chain in general that can be tested, open source software, but also AI models that you can trust, and AI applications you can trust. We haven't even defined yet what open source AI means today. We don't know what it is that should be open. The weights, the parameters, the training data, the results, everything, something. So there's work to do here in defining what this openness and the radical software candor can mean. We need to do source code review, peer review. We need to do vulnerability disclosure. And for those of you who are new to the term, although it's called vulnerability disclosure, you don't disclose. You receive the disclosure from the ethical hacker. But this world is full of weird terminology that misleads you easily. But everybody who produces software should invite others to tell them what's wrong with it. That's the principle of radical candor that Kim Scott came up with. And we should publicly disclose breaches and certain incidents. Not all of them and not immediately, but we need to have a practice of sharing the bad news as well, because that's the only way to make it good news. And when we do that, we take away the stigma, we take away the shame of having a vulnerability, because everybody has them. HackerOne has discovered 500,000 vulnerabilities in its history. It finds one critical vulnerability every hour, and then our customers need to fix them. So if there's somebody here who thinks that they have no vulnerabilities or that you couldn't admit it, just go ahead, because everybody has them. And the faster we can fix them, the better shape we will be in. So I'll end with a quote from Bruce Schneier that he said, such a long time ago, he may have forgotten about it. I found this 10 years ago, maybe more. I think this is just perfect truth and beautiful science. Public scrutiny is the only reliable way to improve security, while secrecy only makes us less secure. It's that simple. So with that, I think together we have a power now that we never had before. The open source communities are much larger than before. Ethical hacking communities is millions of ethical hackers today, and they're partially different people. On the third sector, we have not just the Linux Foundation, we have many other foundations doing excellent work. The private sector is engaged in this. Google, Microsoft, Amazon have giant open source budgets today. And on the public sector, we see specifically the US government do very well here with NIST frameworks, CISA acting on this, many other initiatives that we didn't have 10 years ago. So this notion of working together is actually happening, and it's actually much better than it was just a few years ago. So with that, thank you very much. Thanks for listening, and thanks again, Bruce, for your great quote.